Okay, this is going to be quite a long video, and there's an applet involved which I will put in the notes of this YouTube video so you can have a look for yourselves. Okay, it says two planes have equations pi1 4x plus y plus z is equal to 8 and pi2 4x plus 3y minus z is equal to 0. Find the cosine of the angle between the two planes in that form, square root of p over q, where p and q are integers. If we just look at our applet for the moment, now you can look at this in 3D if you want, and I'll show you how to do this at the end. In fact, no, I'll show you how to do it now. So if you want to look at it in 3D, you have to click here, and then onto the glasses. I think on the online version that appears over here. Okay, but we're just going to look at it like this. So we've got two planes. This is the first plane, and this is the second plane, and we can look at it from different angles here. Okay, and the first step we're looking at the angle between the two vectors, and in order to do that you need to find the angle between the two normal vectors of the planes, and what you're finding is this angle here that you can see here, this angle here, and that's the same as this angle here. Okay, which is the angle between the two normal vectors. Okay, so I'm just going to put that back like that to begin with. Okay, that's how do we do that? Well, this is going to involve using the scalar product. So writing the two planes out, and then converting them into what was known as normal vector form. That's quite simple because the normal vector, this one's going to be 4, 1, 1, and the normal vector, this one is 4, 3, minus 1. So normal vector form is going to be R stands for x, y, z. 4, 1, 1 is equal to 8, and pi 2 R is going to be 4, 3, minus 1, which is equal to 0. So that's quite straightforward. This is called the normal vector of 1, this is the normal vector of 2. We saw those normal vectors on the thing. So the angle between the two planes is the same as the angle between the two normal vectors. So all we need to do is find the angle between these two normal vectors. So cos theta is equal to n1 dot n2 divided by the absolute the magnitude of n1 times the magnitude of n2. So putting the numbers in, cos theta will be 4 times 4, 1 times 3, and 1 times minus 1. Be careful with minus signs, please. That's why I put them in brackets. Divided by the magnitude of this one, that's 4 squared plus 1 squared plus 1 squared, and then 4 squared plus 3 squared plus minus 1 squared. So cos theta is going to be 16 plus 3 minus 1, 16 plus 3 minus 1, divided by the square root of 16 plus 1 plus 1, which is root 18, and the square root of 16 plus 9 plus 1, which is root 26. 16 plus 3 minus 1 gives me 18, and we get root 18 divided by 26. Now we have to give it in this format. So if we multiply top and bottom by root 18 for rationalizing, then root 18 times root 18 will become 18. So we get 18 over root 18 over 18 root 26. The 18s will cancel out, and that becomes 18 divided by 26 is the same as 9 over 3. We can take the square root of all of them, and then we have it in the right format. Let L be the line of intersection of two planes. Show that L has the direction -1, 2, 2. Show that the point A, 1, 0, 4 lies on both planes, and write down the vector equation of L. So going to my diagram, what we're trying to find here is we can see that these two planes intersect on a line. This line is roughly here, and we've got to find the vector equation of this line. Sort of it's guiding us to do it. Okay, so now the directional vector of L is the cross product of L1 and L2. If you find the cross product of N1 and N2, what that gives you is a vector which is perpendicular. Sorry, let me just move that around again. What that gives you is a vector which is perpendicular to these two, which is along the line of the intersection. Okay, It's a bit hard to see it like that. Let's have a look at it like this. You might be able to see it a bit better. Okay, if you see a line coming out of here, that will be perpendicular to both M1 and N2. So you have to find the cross product of those two vectors. Right. So the cross product is done by making a determinant of the matrices. So put I, J, K. These are the two matrices we consider. Just consider the normals. So we're going to put in 4, 1, 1, 4, 1, 1. And then underneath 4, 3, minus 1. 4, 3, minus 1. And then what we do is we cover up this one and find the determinant what's left. So it's 1 times minus 1, minus 1 times 3. Lots of I. Now the next one's always minus. Now we cover up J, so we're going to do 4 times minus 1, minus 1 times 4. We need to be very careful with minus signs here. It's very easy to make a mistake. J. Covering up the K, we're going to do 4 times 3, minus 1 times 4. Lots of K. Right, so just write that out again. There we go. Right, so that's going to give me minus 1 minus 3i, minus 4 minus 4j, plus 12 minus 4k, and then minus 1 minus 3 gives minus 4. So you need to know your negative numbers. Minus 4 minus 4 gives you minus 8, that will give you plus 8j because of that minus sign there. And then 12 minus 4 will give plus 8k. They're all divisible by 4, so that will be minus I plus 2j plus 2k. And you should do that because it makes everything more simple if you do that. So the directional vector is v minus 1, 2, 2 as required. So at the point A1, 0, 4, we'd have to verify that this point is on both planes. So if it does, they intersect at that point. 1, 0, 4. So for plane 1, that's going to be 4 times 1 plus 0 plus 4 is equal to 4. That gives you 4 plus 4, which is 8. And that's what we wanted the first plane to be, 8. So that's okay, that's on that plane. And then for the second plane, it's 4 times 1 plus 3 times 0 minus 4, which gives 4. Take away 4, which is 0, which is on plane 2. And therefore, because it's on that point's on both planes, that's where both planes intersect. So we need to acknowledge that plane 1 and plane 2 meet at point A. 3. LR is 1, 0, 4. OA, the point on the plane that we just found, plus lambda times the directional vector, which we've just found as well, minus 1, 2, 2. Well, this we verified this point on both planes, and this we found using the cross product. Okay, going to this, let's just put it in sort of a reasonable way. If we click here now, what we see here is we see a little red vector here. That's the vector v. There's the two normals. Okay, and this is the directional. This is the vector equation of the line where the two lines meet. And if we look more carefully, we can see. Not quite so easy, but we can see that the vector v, this vector here, is at right angles to both normals of the plane. Okay, and there is the point A. Okay, so that gives me the vector equation of the line of intersection of those two planes. So B is a point on plane 1. So we call this AB1. Given that AB is perpendicular to L, find the value of A and the value of B. So OA is 1, 0, 4. OB is AB1. We had to find the vector AB. Now to find the vector AB, you go AO plus OB. So AB will be minus 1, 0, minus 4, plus AB1. So it's going to give me A minus 1, B, 0 plus B, and minus 3. And now the AB dot the directional vector of the line V must be equal to 0 because they are perpendicular to each other. So perpendicular vectors, that's the condition for perpendicular vectors. So we've got a minus 1, b minus 3 dot minus 1 to 2 is equal to 0, and then multiplying out we get a minus 1 times minus 1, being careful with minus signs, b times 2, and then minus 3 times 2. So we're going to get minus a plus 1 plus 2b minus 6 is equal to 0. So that's going to give 2b minus a 1 minus 6 gives me minus 5 is equal to 0. And now this point B, A, B1 is also on plane 1. Now we have to be careful because we have two unknowns, so we're going to need to make two equations. So we've got 1, this is the tactic. So we've got to find another one. So we know it's on plane 1, so B 4x plus y plus z is equal to 8. So 4a plus b plus 1 is equal to 8. That gives me my two equations that I need to now solve simultaneously. So labelling up 1 and 2. From 1, I'm going to make a the subject, so get a is 2b minus 5, and then substitute it into 2. We're going to get 4 times 2b minus 5, 4a, plus b plus 1 is equal to 8. So it's going to give me 8b minus 20, plus b plus 1 is equal to 8. That gives me 9b, so I've got 8b and b, which is 9b, minus 20 plus 1 is minus 19 is equal to 8. 9b is equal to 27, taking the 19 over, and b is equal to 3. Substitute that back into here. We're going to have that a is 2 times 3 minus 5, that's 6 minus 5, a is 1, and that gives a is 1 and b is 3. So we go over to here, and I'll click here. Okay, now what I can see now is my point B. I could move the sliders a little bit, and that would, you can see that will change the angle. I wanted the angle between AB and the line to be 90 degrees. You can see it from that there. Okay, you see here that the angle here is 90 degrees. Which is what was required. Okay, you have to show that the magnitude, AB is 3 root 2, the length of AB is 3 root 2, so AB is a minus 1, b minus 3. Putting my values of a in, so it's 1 minus 1, minus 3, minus 3, which gives 0, 3, minus 3. So AB will be the magnitude of AB, which is the square root of 0 squared, plus 3 squared, plus minus 3, all squared. Make sure you put it in brackets, which gives you root 18. Root 18 is 2 times 9. The square root of 9 is 3, so it's 3 root 2, as required by the question. Right, and the final part is usually the most difficult bit. Point P lies on L such that angle ABP is equal to 45. Find the coordinates of the two possible positions of P. So OA is 104, OB is 131, and OP, well, P is on the line, so it has to have this format: 1 minus lambda, 2 lambda, 4 plus 2 lambda. So BA, because that's what we need to find. We need to find BA and BP to find that angle. Will be BO plus OA. So that's minus this one, so change all the signs on this one, plus this one, that's going to give me 0 minus 3, 3. And similarly BP is going to be BO plus OP. So again, negative this one with this one. So that's going to give me minus 1 plus 1 minus lambda, that gives me minus lambda, minus 3 plus 2 lambda, which I'm going to write 2 lambda minus 3, minus 1 plus 4 gives me 3 plus 2 lambda, which I'm going to write as 2 lambda plus 3. Right, so using the scalar product, cos of 45 must be BA dot BP over the magnitude of BA over the magnitude of BP for this angle to be 45. Now the cos of 45 you need to know that it's 1 over root 2, otherwise you're going to be rather stuck with this. So we have to do 0 times minus lambda minus 3 times 2 lambda minus 3, 3 times 2 lambda plus 3 over the magnitude of 0 squared plus minus 3 squared plus 3 squared, again put that into brackets, divided by the magnitude of minus lambda squared, 2 lambda minus 3 all squared, 2 lambda plus 3 squared. Writing that out again. Right, so on the top we're going to get minus 6, nothing from there, minus 6 lambda plus 9 plus 6 lambda plus 9 over nothing from there. We're going to get 3 squared plus 3 squared, which is 9 plus 9, square root of 18. And here we're going to get lambda squared. Now expanding this, you're going to get 4 lambda squared minus 12, because 2 times minus 3 times 2 is minus 12 lambda plus 9. And then from this one, we're going to get 4 lambda plus 12 lambda minus 9 plus 9. So you need to know how to expand a plus b all squared there. Right, cancelling out a little bit on the top. So we're going to get 1 over root 2 is equal to 18 on the top, times the square 3 root 2, which we've already done in the previous part. And then we've got lambda plus 4 lambda plus 4 lambda, which is 9 lambda, sorry, 4 lambda squared plus 4 lambda squared plus 4 lambda squared, which is 9 lambda squared. And 9 plus 9 is 18. Common factor of 9, we'll take that out. The square root of 9 is 3. Multiplied by that 3, we're going to get 9 root 2. And then on the bottom, we're going to get lambda squared plus 2. The root 2's will cancel out, because if you take that up there, they'll cancel each other out. The 9 and the 18 will cancel out, so we've got 2 here, and I'm going to take this up here. So we've got square root of lambda squared plus 2 is equal to 2. Squaring both sides, we get lambda squared is plus 2 is equal to 4. Lambda squared is equal to 2, taking 2 from both sides. Taking the square root, we get plus or minus root 2 for lambda. So OP was originally that, and then putting my value of lambda in, so when lambda's minus 2, get 1, sorry, when lambda's minus root 2, we're going to get 1 minus root 2, which is 1 plus root 2, minus 2 root 2, 4 minus 2 root 2, or when lambda's equal to root 2, we're going to get 1 minus root 2, 2 root 2, and 4 plus 2 root 2. Okay, and if we look back at this, okay, and click the last one. Okay, I've actually got it roughly in root 2. This parameter here is near enough root 2. And we can see that the angle here is actually nearly 90, approximately 90. So that means that one's 45 and that one's 45, which is what was required. So there are 2 positions, one there and one there. Okay, and if we do this anywhere, there'll always be 2 positions, but it's this one that we need to find. Okay, it's very difficult to get near to it, but with the arrow key on your computer, you can actually get to the point. That's about as close as you can get. Okay, now if you want to see this applet in 3D, then you click on this and then go like that, and then you have to put your red cyan glasses on. Okay, and then you'll get to see it in 3D. As I say, I will put the applet into the notes of this video. Okay, hope you've understood. Sorry it's such a long video, and thank you very much for watching.